Okay, Vijay, let's proceed ahead with your technical scenario for thermodynamics, and you are going for BARC, right?
Yes, sir.
Okay, so thermodynamics, which part in thermodynamics you are prepared?
Basic thermodynamics, sir.
Okay, can you make a schematic diagram of heat engine?
Yes, sir.
Okay. Now reverse this engine and just tell to see what you get. Reverse this engine now.
Sir.
What did you get in this, Vijay? Now once you reverse it,
So we get heat pump or refrigeration.
you get
Heat
heat
pump or
pump or
refrigeration.
refrigerator.
Yes,
How
sir.
do you know it's a heat pump or it is a refrigerator?
So because it is a work consuming cycle, sir.
No, by seeing this, how do you know that it is heat pump or it is refrigerator?
Sir, if the efficiency is more than 100%, it is heat pump or refrigerator, sir. So we define it by coefficient of performance.
Okay. How do you define COP, coefficient of performance?
So coefficient of performance is equal to for refrigeration it is QL divided by W input, sir. For heat pump it is QH divided by W input.
Okay. Now COP, when you say why it is not used, the term efficiency is not used.
Sir, because for heat pump, if you try to find out the efficiency, it will be more than 100%. But we know that efficiency cannot be 100%, more than
There's another
100%.
term called effectiveness.
That's
What
used
is that?
from zeros. Sir, effectiveness is the actual heat transfer divided by maximum possible heat transfer.
And what is effectiveness? How it is different? Effectiveness?
Sir, effectiveness is generally used in heat exchangers,
Okay.
and it gives the ratio of actual heat. I mean, it is a factor that relates the performance of the heat transfer.
Now you have made a schematic diagram of heat engine and refrigerator or pump.
Yes, sir.
How you can maximize the efficiency or COP of this?
So COP or efficiency, sir? You're asking COP or efficiency,
I'm
sir?
saying COP and efficiency, how to maximize these two? If you have to maximize efficiency, how shall you do that for engine?
By reducing the friction losses, sir.
No, no. So you know there's a reversible engine also?
Yes, sir. Carnot engine.
How do you get the efficiency of Carnot engine?
1 minus TL divided by TH, sir.
How do you maximize this efficiency of Carnot cycle?
By reducing the TL or by increasing the TH value, sir. Temperature limits. By changing the temperature limits, we can increase or decrease efficiency.
And reverse Carnot cycle also gives you COP, right?
Yes, sir.
And how much is that COP? How to maximize that COP?
For that COP, we have a formula like for refrigeration, it will be TL divided by TH minus TL, and for heat pump, it is TH divided by TH minus TL, sir. So, So for refrigeration, by increasing the temperature limit, lower temperature limit, we will increase the COP of refrigeration, sir. For
Mm-hmm.
heat pump, it is TH, that matters. If we increase the TH value, then we can get the maximum efficiency.
Okay. So refrigerator and heat pump. If I give you schematic diagram, by seeing schematic diagram, can you identify whether it is a refrigerator or a heat pump?
So no, sir, we cannot identify if it is a refrigeration. I mean, we need a COP value, sir.
Is there any relationship between the COP of heat pump and efficiency of heat engine?
So COP of heat pump comes out to be 1 by efficiency of heat engine, sir.
Hmm. So when I reverse heat engine, don't you think I should get pump and not refrigerator?
For reverse heat engine. Sir, actually, basically the cycle becomes the same, sir. But we are concerned more about QH value for heat pump. But for refrigeration, we are concerned about QL value, sir. That's the basic difference.
Hmm.
But the working principle remains the same, sir, for refrigeration as well as heat pump.
Hmm. Okay. So where is the application of the heat pumps?
Sir, where where the ambient temperature is very much higher, there we need to maintain the room temperature to be higher as compared to the ambient temperature. There, heat pump finds applications.
But normally we use heater instead of heat pump. What is the difference? Can air conditioner be used as heat pump? The AC which you use, summer AC,
Yes, sir.
can it be used as heat pump?
Yes, sir. We can use it, sir.
How? Let's say we have AC at home. How
Yes, sir.
shall you use it as as a heat pump now to heat up the space?
So instead of in AC, the heat is rejected to the atmosphere, and the cooler is passed through room. So basically, we can change the evaporator and condenser function, sir. Then that will behave like a heat pump.
Hmm. Will change what?
We'll change the, I mean, evaporator and condenser, sir. The function we will reverse it. In AC, the condenser in condenser the heat is rejected, right?
No, but do you need vapors and all in heat pump? Or suppose I blow air on heater, it will serve as the purpose. Okay, you know psychrometric chart?
Yes, sir.
For heat pump, can you draw the process on psychrometric chart? No, but you have not made psychrometric chart. What have you done?
So, here, sir.
This is not a psychrometric chart. Okay, last me. It is not visible. Show me again.
1 minute, sir. TBT and specific.
Show little above. Hmm. So you are raising the, you are heating and humidifying this
Yes, sir.
process, huh?
Yes,
So
sir.
tell me at home, how shall you create this heating and humidification? In air conditioner, what kind of process do we get?
So an air conditioner will basically suck in the room air, and then that is evaporated and heat is released. That is cooled and then it is circulated back to the room.
What process? I mean, on psychrometric chart for air conditioner. So that means this is a reverse of what you have already earlier made. Tell me, how shall you convert AC into heat pump? So if you remove the condenser, what
Yes,
will
sir.
you put in place of condenser?
So we can have a heating coil, sir.
Okay. What else?
But heating the temperature does not change the humidity. So we can also
So now
have.
tell me, in the kitchen, do you get heating and humidification process in the kitchen?
Sir, in the kitchen, we use exhaust to remove
Suppose I
the.
keep a pot in the kitchen with the
Okay, sir.
water in that, and water is boiling.
Okay, sir.
On psychrometric chart, how shall you draw this process?
In boiling, we increase the temperature, so dBT increases, and water is getting into water vapor. So that's
So
why
that is
humidity
the
will
same
increase.
as heat pump, right?
Yes, sir.
So can I create a heat pump in the room by putting a pot and water in that and boiling it? But kitchen is not comfortable.
By boiling it, we can. Yes, sir. We can do it, sir.
Okay. Are the both the processes same? Do you think steam and superheated steam is same thing?
No, sir. Superheated steam will be at higher temperature and pressure.
Psychrometric chart, में what do you get? Superheated steam or steam?
Just steam, sir. Just vapor.
In psychrometric chart.
But the temperature, I think the order of the tribal temperature will be lesser, much lesser as compared to superheated steam, sir. In turbines, and we handle steam with a temperature where 500 degrees Celsius and 700 degrees Celsius. That's higher, way much higher as compared to cyclone.
Okay. Okay, Vijay, let me give you the feedback now. So,
Yes,
Vijay, they will just check your thinking, how it is going, which direction it
yes,
is going, what you are answering, and all. Sometimes
yes,
they will ask you to manipulate the things, I mean, reverse it. So, how do you know whether it is a refrigerator or it is heat pump? It is only on the basis of the conditioned space. Which
yes, sir.
space you are keeping in the controlled temperature. In the heat pump, higher temperature is kept at the higher temperature body is the conditioned body.
Yes, sir.
And in the refrigerator, lower temperature body.
Yes, sir.
So your focus in the refrigerator is on lower temperature body, and your focus in the heat pump is on higher temperature body.
Yes,
And psychrometric chart actually is plotted for superheated region. It is not wet region. That is how
okay.
psychrometric charts are plotted. Yes, reverse of air conditioning is heat pump activity only, but in the room when you keep water boiling, then the steam cannot be controlled. I mean the humidity which you want. It is at
Yes,
particular humidity level at which you feel comfortable. So that
yes, sir.
humidity level may not be controlled very much, right?
Yes, sir. That's
So
right.
you need to have superheated state of vapor. So moist air is something different from this, right? So you need
Yes, sir.
to take care of that. So these are a couple of questions which were asked, and it is checking your thinking in that direction, how it is going. So how to make the engine more efficient is by making it reversible, and most efficient is Carnot. And to increase the efficiency of Carnot, either raise the higher temperature or lower the lower temperature. COP may raise the lower temperature and decrease the higher temperature. Something like that you have to do. The
Yes,
rest I think is okay, but thinking you need to, I mean they will force you to think a lot in BARC,
yes, yes,
right? Chalo
yes,
practice more on this, huh?
yes, sir. Sir, how many snap interviews can I give?